So before we start any conversation about the thermal subsystem, I thought that we can go back to the fundamentals. So the thermal subsystem hinges on the concept of temperature and heat. So what is temperature? It's some manifestation of thermal energy. There's a colloquial phrase that it's a measure of hotness, but this can be more rigorously defined with kinetic particle theory, which is it provides a microscopic account of temperature for some bodies of material. It's based on macroscopic systems being composed of many microscopic particles, such as molecules and ions of various species, the particles of a species being all alike. So you can see here the distinction of different phases of material. So for kinetic theory, what's important is that solids are close together. The particles are close together in a regular pattern, and that heat is generated by vibrations on the spot. Liquids, the particles are close together but are in a random arrangement. The movement of the particles is that they slide and slip across each other. For gases, the arrangement of particles is far apart, random arrangement, and they move quickly in all directions. So fundamentally, you can think about temperature and heat as the movement of particles in a phase of material. So what is heat? Heat is based on thermal energy, but instead of it being a static state, it's more about the transfer to or from a thermodynamic system. So temperature is measured in degrees Celsius, Kelvin, Fahrenheit, and Rankine, but heat is measured in BTU, British thermal unit, calories, or joules. For this course, we're going to be mostly concerned with Celsius and Kelvin, and then joules. Okay, and then heat capacity is the amount of heat to be supplied to a given mass of material to produce unit change in its temperature. It is a physical property of matter. Heat capacity is what connects heat and temperature together.